This isn't going to be a long stream because I ended up, instead of starting the other stream working on QTalk, I got inspired, or I had an idea, and then it caused me to change like one convention, naming convention, and how I've been doing this faceted stuff. And it sort of ripples through the whole library to make it a lot more natural and like Go idiomatic, less verbose. It feels a lot simpler now, combined with other stuff that I did today. But I just did the sort of name change throughout the API and fixed some other things, and now all the tests are passing, so it should all be fine. And so I kind of want to just show it off. Just kind of a interesting API design case study, I guess. I'm not gonna let it wait the whole 10 minutes, but we'll go get some water. Let me pull up the old thing to compare. Guess I can update this. I'm gonna try to explain this. Hopefully, though, you already have some context. But so we have this faceted data structure system that I'm sort of building up. It's sort of a pattern that I'm creating a particular implementation for. I don't know, there's a lot of interesting things that I'm discovering here, so I don't know what, you know, the real magic is, but I think there is something to this faceted idea. And I guess the way that came to me today is a good way to explain it. Sort of like entity component system, ECS meets aspect-oriented programming. Because in a way, like when I originally discovered aspect-oriented programming, it sounded really cool. And then I realized it wasn't exactly what I thought it was. Very kind of overcomplicated. And so these are facets, are sort of like aspects, because of the focus on implementing an API. But they can also be used like in ECS, where they're data components. You can be data oriented. So in this implementation, we have an entity that has a string ID, and you can just put facets on there. Facets are just structs. In this case, we have some built-in facets that become sort of conventions that we then start building on. So, just as context, I guess it wouldn't hurt to show the new version just for this structure. But basically, an entity has an ID, and then it has a list of facets. And a facet is basically any struct that implements an identifying method, which is like facet. And so it's going to return a facet ID, which is just a number that you usually get from next facet, which is just an incrementer. It sort of cleans up some of that API is already kind of cleaned up. Anyway, so we have a value facet as one field value. And so now this entity is or has a value, and we can treat it that way. Getting the value is kind of complicated, because the way you might do this without any helpers is you would, on the entity, you'd say get value facet ID, and then you'd have to type assert to value facet, and then you can get value. So we create helpers like this that will give you the string or the interface value given an entity. In this case, it's called the function helper in this case is called value, which is interesting because it's kind of a different naming convention than a lot of the other stuff. But so then to sort of introduce some structure, we create an entity with a list facet, which has no values to initialize, but in order to get its API, we call a list facet. So there's a convention of having these getters that for any type of facet, it will get that type from an entity. So then we create some more entities that have values. We could call them value entities. And then we can append them to our first entity using the API that the list facet gave us. And the list facet is basically a wrapper around a slice. So you can do most of the things a slice can do, and you can also just get a slice. But again, we can iterate over them and get their value. So value becomes, a sort of building block. Another building block is a key facet. So maybe an entity is both a key and a value, like a key value pair. And if you were to put those in a list, you can kind of treat them like a dictionary, because now along with value, you can also get the key. And we even have a sort of helper that sort of takes that convention and encodes it into something that lets you give it an entity and a key, and it'll give you the value of the entity in the list with that key. So it gives you sort of ordered dictionary. And you can see that we have some utility functions that do operations on lists. And it's just more complicated. Now we're doing a tree node. So they have children and a parent. But it's interesting to note that the children is actually a list. So it has the same API as before, and we can even use list utilities on it. And again, because these APIs return oftentimes an entity or a interface, you need to get a particular facet interface, you usually need to do this, which is a convention. So if you wanted to make a custom facet, this is how most facets kind of looked until just a little while ago. So first you'd create a sort of global variable in this package, whatever your package for this facet is, called let's say the name that for our facet is custom. So this gets into the naming convention stuff. So we'll create an ID, a unique facet ID for this. We'll call it custom facet ID, which we basically use. I guess this normally would be facet. This is an old code I tried to update. So that makes this a facet. It implements the facet interface. And our type is called custom facet. And the reason why it's not just custom was because it very often you're going to implement an interface as well. And my preference in the same namespace is to have the interface have the more canonical name. And then you have something like, never like implementation or something like that, but somehow name your actual main implementation struct something else, even if it's just like, an unexported version of the name. But because we have a couple of things that are using this name, we need to... There's some thunder. I don't know if you could hear that. So anyway, we'll call it custom facet. So whatever our name, and we put facet on the end. The reverse, facet custom, is sort of the convention for the getter that given an entity will give us that facet, which just calls get on the entity with that custom facet ID. I didn't update that either, sorry. And then it type asserts it to the right thing, and there, you're good. And then this is mostly, some of this might be redundant when we have generics, but this is kind of designed with generics in mind. But it's interesting that this does something that I guess is more orthogonal to generics than I thought. Okay, so the change came when I realized, well, the change came with basically changing. So let's say this is a bad example because we don't have an interface. I've already changed it, but let's pretend this is how it was before. Right, so we have a tree node and we define its interface, and if you're really gonna do this, let me just revert this because I think I can, maybe a simpler one. But like this became so much more than just changing the naming convention, because it changed the whole feel of the API. So the idea was, and again, it's weird because I normally don't want to call the interface something different. Usually I want that to have the main word or label that you're using. Because if you're using interfaces, that probably means that you want to actually use them all over the place, so why not make that concept, whatever it is, abstract, and say the canonical thing is the interface, if that makes sense. Some people have dealt with this by calling the interface, like they'll have a type like player, and that's a struct, and let's say they have an interface for it, they'll call it player face or something. Like that's the closest thing I've seen to a like interesting convention in the Go world. Other places as well. I mean, there's sort of the classic like perpend with an I that you got with Java, and then was replicated in other places like Python and in places, and probably in Go. There's probably Go that does that as well, even though I don't think it's really Go idiomatic based on the Go standard library and such. But what's interesting is not only did this sort of flipping of using facet at the end of the interface instead of the implementation, it helped a bunch of other things kind of lined up conceptually for me. So first of all, it sort of puts the emphasis of facets on interfaces, right? Even though we're going to call this struct a facet, the type that has facet in the name is an interface. And so that sort of, more closely ties the concept of facets to interfaces, which I think is what makes it different than ECS, because in ECS, an entity and a component is just data. The whole point is to not have any logic associated with it. You can do that here, but we're doing this for a different reason, because we want to use these interfaces to basically make a generic API. And what I realized was list facet. Did I fix that as well? That's a list, but this should be a list facet. The interfaces that you design are going to either work with entities or facets. And I didn't really notice that before when I'm seeing, just like node and list here. But that's kind of one convention here, is you're designing APIs to either work with entities or work with facets, which are these generic interfaces. And then your actual implementation can just be called node, and so you don't have facet before it. And in fact, I even just shortened other conventions, like instead of saying, custom facet ID, why not just custom ID? So node ID. And then the other change was now that, I mean, we could use facet custom, but I think, I'm trying to remember which type I might have run into this problem, but I realized it made a lot more sense and was actually more idiomatic to common Go APIs to use the from convention. So for example, sometimes you want to get a value out of a context. Oftentimes you'll have that type from that takes context. I've used this in other places, but from is a pretty common convention for sort of getting something from something else. And so it makes a lot of sense here and actually makes the API flow a lot better, because now the accessor is starting with the type name. So when you actually call it, it takes advantage of the package name. So it'd be tree node from, right? So it sort of reads more clearly than tree facet node. And so that became that new convention. And then the only place where this really didn't work was back with our basic key and value ones, which, because if we call the type key, then our getters for those, which used to be just key, wouldn't work. So because these are getting values out of it as opposed to the actual kind of struct, I went with the of convention, like reflect value of. It's really not that different, like you could use from, but it seemed to make sense to do something a little bit different in this case, because we're not actually returning a struct facet type or something like that. So same with values, now value of. So looking at this, I felt like I got pretty lucky that this felt rough, fairly ergonomic, like I could see myself writing this code. But then after doing this switch and converting the whole API, I was like, this is way better. So already, just because you end up using the concrete types more often in your code, so it makes more sense to actually have them be the shorter canonical name. And then the fact that the interfaces are still very important, we suffix them with the name of this whole pattern so that we kind of associate that with it. And that also helps in the API, because you're going to see that you're either working with entities or some kind of something facet interface. So we could have written this like this, but at this point we might as well just do it that it's a single value thing. And even though VS Code complains because it's a baby, I'm going to do it that way because it looks so right? So again, here's another one. I was having problems with list, because the list package has both an element and a list, right? And this happens sometimes. You have to use the name of the package as the type, and you get that kind of redundancy. So that meant that some of the getters for these were facet element and facet list. And so going to the from, again, putting the name at the front suddenly makes this open up a lot of nicer possibilities, because a lot of the time you might want to shorten something like this. Like if the list is the primary thing, then maybe you can shorten that helper to just say list facet, right? Because it's going to get the list. But that wasn't very clear and wasn't very consistent, so I went back to this convention. But when switching to the from, it actually made a lot more sense, because we can say element from, and we could say list from, but we could also do list from, and it becomes way more clear, right? We get we're sticking to a convention, like just a number of conventions are just lining up, and makes this make more sense. So that's sort of an ideal API, and so that, there's not too many cases of that one, so that's the only case we'll see just from. But so list from, and already this is kind of making more sense to me, like a new entity with a list, right? And so, okay, list from is giving us the list from that entity. Create some values. Again, this is way less verbose. It's the same API, just some naming conventions changed. Here we're using value of. Same with key, we can do the same thing. Tree node from. See, in our code, when we're writing it, we hardly ever write the name of the interface. So it actually kind of does make sense to make the more verbose name used for the interface. The problem is, like I said, I try to avoid that because I believe that the interface is semantically a higher priority most of the time. And so here's our new version of custom, just custom ID. Custom, like any struct, it's not facet or anything, just custom, or whatever name you want to give it that name. Implements a facet that returns its ID, and then you create custom from, or whatever makes sense within that kind of convention. And again, the benefit is the code that we write the most is going to be shorter. We're using the shorter names. We don't have extra whatever. But then it's interesting because it sort of creates a convention where anytime we see an interface with facet, we know it's a particular kind of interface. It's an interface that's going to either work with entities or other interfaces that have facet in them. They could be other interfaces as well, but most likely you're building this structure out of this structure, so it's going to use facets. But so anyway, that, and the ripple effect again, kind of like in terms of naming and stuff, accessing embedded things. So component, instead of whatever it was, element facet, we're just using element. If we need to, I guess we don't in here. I've also been converting some things to values instead of pointers, because I guess I kind of maybe better understand the addressability of certain values now. And I love the way it worked out, where if we want to create a facet, and we can still call these facets, but we just don't have to name them that. Earlier today, this development came up. It was kind of nice. The idea was, it's a pretty common thing to have a reference back to the entity for a particular facet. So you end up doing something like entity and then a pointer, FDS entity. And then you'd have to implement something that returns it or whatever. But then setting that is kind of inconsistent. Like you'd kind of have to do it for every type, or implement a setter on every one of these or something like that. And luckily, we kind of were able to just create a type called an entity facet that just wraps an entity, and so this becomes sort of like the a base for creating facet structs. And you don't always need to do this, but it's common enough that this is kind of a nice thing to have, because it'll implement entity for you. It can also implement set entity for you, as well as a kind of a convenience method for the changed signaling stuff that we added today. So you don't have to check for nil before you call changed, as well as the fact that usually you're calling this on the entity, so you're not going to be passing a different entity, so it'll be nil. So this simplifies that API quite a bit. And then if you ever need to set the entity on something, you can just kind of type assert here, which then that became incredibly helpful, because that becomes a standard way to automatically set the entity ID whenever you add a facet to an entity. That's a huge thing today. I was like, what the hell? Why didn't we do this before? Whenever you add a facet, it'll just check to see if you can call set entity on the facet, and we'll set the entity. Easy. And so most types that need to embed a reference to an entity for whatever reason can just say entity facet, and then they can take advantage of all of those. So it simplifies a lot of this code. I mean, this whole system is trying to simplify and get rid of redundancies, in a different way than like object-oriented programs tried to. The inheritance model, I guess, was the real flaw of object-oriented programming. But the idea of like interfaces and message passing through methods, and even though it's sort of bastardized into this sort of like functions attached to structs, which ends up being the most elegant, like Go has the most elegant, I think, implementation of object-oriented programming in a C-like language, right? And that's important because a struct is just a struct. It's like the simplest chunk of typed memory. Anyway, because what this is doing is ultimately reducing the that's the other thing, is all our utilities now will have facet. They also either work with facets or entities. So it becomes very clear what the right thing to do is for what you're doing. You're making these utility things that kind of build on the built-in methods, try and work with facet interfaces, and yeah, it all works out pretty nicely. So I'm really happy with this. Right, maybe this is sort of a good kind of like example of the general ideas, the closest thing to like the best example of that. Maybe this one. Okay, yeah. So again, it's a subtle difference, and some of it is just, but a lot of it's inspired by the conventions that had changed. So, it makes more sense. You want to make an entity with a list, you make an entity with a list. You want to get the API for that list, you call list from, give it the entity, and now that's what you would call your list methods on. Which of course is implementing the list facet interface, which then allows these utility functions to operate on them, whether or not they're actually a list. Or they can be lists in different contexts, whereas this is a list of children. So anyway, that's pretty much it. I'm probably not going to do any more work today. yeah, I mean, I was already kind of like, oh, this is kind of complicated, and I could probably simplify it a bit, but I actually did simplify it a lot just by going through and doing these convention changes and using more values instead of pointers, because you don't have to check or create, you avoid so many nil checks. So I'm glad I'm getting used to that kind of gray area where it's like it needs to be addressable, but we don't want to deal with the nil values. And I'm it should all work, like all the tests pass, so I don't think I'm totally missing something here, although I could be. Anyway, that's it. I'm also just really excited about the notifications being built into entities. Like it felt very, and it after implementing it this way, it felt right. One idea was creating a facet for change notifications, or you could generalize it to be a whole kind of like signaling or event system, and it still could be actually, but just focusing on changes really helped kind of find this model where the simplest implementation of, and I showed this earlier, the notify package, which is roughly simple. Like it just is saying, there are certain things that you can send notifications to, and that's also the same API as the observers that would then listen to a topic. This is a little bit overmodeled, but it's still pretty simple, and there's some kind of nice stuff in here to suspend and stuff like that. But I didn't need that. I was like, that's the kind of stuff that I wouldn't want to have in the core of this entity business. So I just did the simplest thing, which actually data-wise too is a sync map. Just a little bit easier to work with. It's not going to be used too often. It's usually just setting those up. Although I don't know about the performance of range, but and it being a separate lock from the mutex used for facets, basically. So now we have a change observer, and I might actually change this to go back to something more general, like signal, and actually pass a payload, because I'm thinking of something almost like error, or at least in terms of the way errors are sort of like a very simple, like at its minimum it's a string, but it could be wrapped in more structured data. And I like that idea for signal as well, as a different kind of like events, but maybe something that feels more Go-ish because it's more like errors. I don't know. I mean, it could actually be an error type. That could work, and I could just rename type signal is an error, but we'll see. We'll get to that. For now, it's just saying changed. So change observer, we just store those in our sync map, and we can delete by value. So it's very simple, add and remove API. And then the changed implementation on an entity first sets E to whatever that entity is, if it's nil. This is kind of cool. Before it goes over all your change observers, it'll go over the facets. And this is very similar to this whole thing is very self-similar structurally to the higher level components. Can implement interfaces. I'll get to that yet. But so if facets implement changed, then they can also process these change notifications, and then that's how the tree node is able to propagate changes upward to the parent. So the tree node implements changed and just passes whatever it gets along to its parent if it has one. And so then any change will propagate up the tree. Tree of entities. Even though entities has no concept of parents, but its changes, like, I don't know, this is the magic of interfaces and stuff. Anyway, I guess that's it. I'm just pretty excited by this stupid API. I don't think there's anything else I need to show. I mean, I did some basic tests to see that changed works, and God, it's so cool. Anyway. Tomorrow actually, I don't know what I'm working on tomorrow. Oh, Shell Driver. Gonna rename MacBridge to Shell Driver and start organizing it to be more cross-platform. And then, yeah, I'll probably work on QDoc as well tomorrow. I'm not gonna wait for this timer to end. I'll see you later.